Okay, today we're going to talk about compound inequalities. This is day 3 for section 1.5, but we're doing compound inequalities and. And is different than or. It's a compound inequality, but you must find all the values that make both inequalities true. And you will see that the number lines are either trapped where they overlap each other, or there's no solution at all, okay? So, this is an example of an and statement. Why? Because there are two inequality statements, and there's x in the middle. And what you are going to do is you're going to work this, what you do from one side, you're going to do to the other. So, I'm going to show you what if I were to just have this problem right here. Instinctively, you would want to go ahead and distribute this. So you'd make that a 6x plus a 2 minus a 5 is less than or equal to 11. Well, all you're doing is you're just going to bring the other side down with you. So again, what if I were to have just this? You would combine like terms. So you'd have 6x minus 3 is less than or equal to 11. So again, you are simply going to drop down the negative 3. Make sense? So now, if you were to have this problem, what would you do? You would add 3 to the left, but you're going to add 3 to the left, the middle, and the right now. So we're going to do two problems at one time. So negative 3 plus 3 is going to be 0. This cancels out, and 11 plus 3 is 14. So again, if I cover up and I did not mean to touch that. If you cover up the 0, you are going to have just simply the 6x. So if I do that, it really is touchy there. Things you learn. Divide by 6 on the left, the middle, and the right. So 0 is less than x, which is less than or equal to. Divide them both by 2. The 14 and the 6 are both divisible by 2. So what's 14 divided by 2? That's going to give you a 7. And 6 divided by 2 is going to give you a 3. That is an example of an and inequality. How do I graph that? I put 0 on a number line with an open dot. I put 7/3 on a number line with a closed dot. And where's x? X is between the two numbers, so you simply shade in the middle. Okay? Same concept. Now I have two different equations. Just solve them both. So if I do that, I subtract 1, and I have 6 is less than 2x. Divide by 2, 3 is less than x. We don't like the way that looks. We need to pick it up and turn it around. When we do that, the arrow is pointing toward the 3 before we pick it up and move it, so it's going to still point toward the 3 there. So here's one of them. Now I need to go ahead and finish this one, so I divide by 3 and I have x is less than or equal to 6. Now, we need to put those on a number line together. So I have 3 and 6. When it is 3, it's an open dot, and I'm shading toward the 6 because it's greater than. However, if I am going to be 6, it is a closed dot, and I'm shading to the left of it. Now, this one looked very similar in our homework for the or, and we said that it could be any real number when it was or, but this is and. So an and means I only want where both of them will be true. So it's only where they overlap. So how do I write that? I have 3 and I have 6 and I put x in the middle. You are always and forever going to use the less than symbols when it's x's in the middle. But you have to pay attention to if it was a closed dot or an open dot. So at 3 it was open, so you leave it alone. But at 6 it was a closed dot, so you have to put the less than or equal to symbol there. Let's do one again like that, okay? Same concept, divide by 9. I have x is less than negative 3. And divide by 4, x is greater than 9, okay? So this is an and. Since it's an and, I'm going to go ahead and I'm going to put negative 3 here, and I'm going to put 9 there. At negative 3, it is an open dot, and I'm shading down to the left. At x equals 9, it's going to be an open dot, but I want it to be greater than. So, look at that. Is there any overlapping region? Is there an x number that whenever you put it in there, don't make both statements true? And the answer to that is no, they never overlap, so therefore there is no solution to this problem. Okay, let's do it again. Divide by -6. And I have A is, careful, greater than or equal to -3. Over here, subtract the 5. -3A is greater than -3. Divide by -3. An alarm should be sounding because I divided by a negative. So that means I have A is less than 1. So I'm going to go ahead and put these on a number line. Which one's smaller? Is -3 smaller or is 1 smaller? -3 is smaller and 1 is larger. So at -3, I am a closed dot there and I'm shading to the right. At 1, I am an open dot, but I'm shading to the left. Now, this is an and statement. Since it is an and statement, I need to know where they overlap. So they overlap between the values of -3 and 1. So how do I write that? Well, I put my values that I'm comparing, -3 and 1, I put X in the middle. And remember I said we always use the less than statements. But at -3, it's a closed dot, so I have to put the equal to part there. And at 1, it is an open dot, so I leave it alone. Okay? Same thing. So this is the one where it's already set up for us, where it's X is in the middle. So this is where you're going to do to the left, the middle, and the right. So I'm going to subtract 11 on the left, the middle, and the right. So -12 is less than -6x, which is less than -10. So I'm going to divide the left, the middle, and the right by -6. When you divide by a negative, an alarm should be sounding. I have to flip the inequality signs, making that -10 divided by -6 is a positive, but they're both divisible by 2. So that's going to give me a 5/3. Okay, but here's the thing. 2 is larger than 5/3. I have to have the smallest number clear to the left because Math Excel will count you wrong if not. So 5/3 goes first, X is in the middle, and 2 goes last. And what did I say you always have to use? Sorry about that. You always have to use the less than symbols, not greater than symbols, but less than symbols. And you need to make sure that you are checking the signs for closed dot or open dot. And that is already done for you on that. At 5/3, it is open. At 2, it is open. And the shading is in the middle. Okay? Last example. I'm going to add 2 to both sides. So I have -4x is less than or equal to 12. Divide by -4. I'm dividing by a negative. An alarm should be sounding, right? So I flip the signs, and I have -3. Over here, I subtract 1. -x is greater than -1. And then I'm going to go ahead and divide by -1. And again, you should have that alarm sounding off in your head because you're dividing by a negative. So that means now x is going to be less than +1. So these are my 2 values that I need to put on a number line. So if I'm putting those on a number line, maybe, which one's smaller? Is -3 smaller or is 1 smaller? -3 smaller, 1 goes on the far right, and at -3, it is a closed dot, and I want everything greater than that, so I'm shading to the right. At 1, it is an open dot, and I want everything below it. So where do they overlap? They overlap in the middle, which means I put up my numbers, I put X in the middle, and I always use the less than symbols, but I check to see if it's a closed dot, I put the line underneath of it, open dot, it stays. Tonight's homework is 1.5 worksheet 3, compound inequalities and.